In this video, I'm going to discuss about equations which are solvable for x. That means sometimes we'll have some first order differential equation, but not of first degree, and which can be easily written x equals to some function of y and p. That means x equals let's say some function that is f of y and p, and what we do, we'll just differentiate with respect to y. We'll get dx dy equals something, that means we'll get del f del y plus del f del p and dp dy, and at the place of dx dy what we will put 1 by p, because dy dx is p. Now let's understand this by an example. So example is p square y plus 2px equals y. Now see, this can be solved for p, even this can be solved for y, so no problem. We can solve this for x too. So what we will do, 2px equals y minus p square y. Okay, divide by 2p, we'll get x equals y upon p. Okay, so divide this equation by 2p, will get y times 1 minus p square upon 2p. Okay, now what we'll do is y times 1 upon 2p is there, and negative y times p upon 2. So this is the equation. We can write this for explicitly for x. Now differentiate the whole equation with respect to y. So we'll get dx dy, and that is nothing but 1 upon p. On the right hand side, what we'll get 1 by y, 2p square, negative 2p square times dp dy, and then 1 upon 2p, and derivative with respect to y of y is 1, and negative p by 2 plus y by 2 times dp dy. Okay, so simplifying, we'll get 1 upon p, negative 1 upon 2p, this one, and again negative p by 2. Okay, so dp dy times, but we'll get negative y upon 2p square, and here plus y upon 2. Okay, let's simplify these things. We'll get 2p, and then it will get here 2, negative 1, and negative p square. So on the right hand side, we'll get y common, dp dy times 2p square, we'll get negative 1, and then plus p square. Okay, or we'll get 1 minus p square upon 2p equals y times p square minus 1 upon 2p square. This is dp dy, cancel 2p, we'll get here p only. So our p into p square minus 1, negative p square minus 1, and negative y into p square minus 1 dp dy, this is equals 0. Or if we take common p square minus 1, negative p square minus 1, what we'll get? P plus y dp dy equals 0. A first factor, this will leads us to the singular solution. So now from this factor, what we'll get? We'll get dp upon dp dy, this equals to negative p, this is dp dy negative p, or we'll get dp upon p is negative dy upon y, or dp upon p plus dy upon y equals 0. Integrating will get log p plus log y, let's say log c, which is the arbitrary constant. So from here we'll get log py equals log c. So therefore py equals c, or p equals y up c upon y, call it 2. Now put it in the given equation, that is the given equation is this one. Let's copy it, and okay, so this is the given equation. So if we put the p value from 2 in this equation, what we'll get? C square upon y square times y plus 2 into cy x equals y, or c, this will get cancelled, so c upon y, so multiply the whole equation by y, what we'll get? C square plus 2cx equals y square. And this is the general solution of the given equation. Here is 3 questions for self-test. The first question can be solved for x. This can be solvable for p, and the answer is given there. The second and third, these two can be solvable for x as well as solvable for y. And the solution, please look at the solution. The solutions are in parametric form. That means from these two relations, if we eliminate phi value, then we get the relation between x and y. But it is hard to find it is hard to eliminate p values from these two. So we put it in this form where p is a parameter. That's all. And this solution is called parametric solution. And again, for the third one, the solution is in parametric form. P is the parameter. We have two relations for x and y which are in terms of p. So the general solution will be the relation between x and y by eliminating p from these two relations. Thank you.